Hi everyone. Today we will discuss the last topics of this chapter, waves. Okay. In the last class we already discussed what is meant by standing wave and what is the expression for standing wave. From there onwards we are going to discuss today. So in the case of standing wave, now we are going to discuss what is meant by nodes and antinodes. So the expression for standing wave that already we discussed in the last video. Those who are having doubt, you can refer the previous video. So the displacement relation of a standing wave is given by y of xt is equal to 2a sin kx cos omega t. And already we discussed 2a sin kx stands for the amplitude of the wave. So here you can see that amplitude of a standing wave does not remain the same throughout the wave. And it keeps on changing as it is a function of x. That already you can see from the expression. But which is the amplitude here? 2a sin kx stands for the amplitude, and that is a function of x. So we can say that as x changes, the amplitude also will change. So we can say at certain positions the amplitude will be maximum, and at certain position the amplitude will be zero also. No, some position, depending on the value of sine function, some position it will be having maximum value. At some other position, when sine function becomes zero, the amplitude will become zero also. So nodes means it represents the positions of zero amplitude. Where the amplitude is zero, those positions are known as nodes. N-O-D-E-S, not N-O-T-E-S. Okay, nodes means it is the positions they are the positions in a standing wave where the amplitude is zero. And now you may be knowing what is meant by antinodes. No, antinodes means that corresponds to maximum amplitude. Okay. So that is in the case of a standing wave, the amplitude is not constant. It varies as a function of x, or it varies as a function of position. So we can say that at some positions amplitude will be maximum, at some other positions amplitude will be zero. So where the amplitude is zero, those positions are known as nodes, and where the amplitude is maximum, those positions are known as antinodes. Okay. And now we will discuss the expression for nodes and antinodes. So already we know nodes means zero amplitude. So in the case of a standing wave, we can write 2a. That is what is the amplitude? Amplitude can be written as 2a sin kx. So amplitude to be 0 means 2a sin kx equal to 0. 2a cannot be 0. So sin kx equal to 0. So when sin kx will be 0? When sine function takes the value of integral multiple of pi. No. So we can write when kx equal to n pi. Okay. So from that we can find the value of x. How we will get the value of x? Kx equal to n pi, so x equal to n pi by k. Okay, so the value of x represents positions of nodes where amplitude is 0 is given by x equal to n pi by k. And what is k? K is wave number. Okay, so whichever position satisfies this expression, those positions will be of nodes, means 0 amplitude. And we know that wave number k is given by wave number, that is equal to 2 pi by lambda. So that we can substitute in the previous equation. So what you will get? X, we will get it as n lambda by 2. N stands for 1, 2, 3 onwards. Okay, all integer values. So we can say that half a wavelength or lambda by 2 separates two consecutive nodes. No. One node came, after that next node will come after lambda by 2 separation. Okay, is it clear? So nodes means those positions in a standing wave where amplitude is 0, those positions are known as nodes. So we will get by equating the amplitude expression to 0. So 2a sin kx equal to 0, or we can write kx equal to n pi, or from that we can write x equal to n pi by k. And if we are substituting k as wave, k is the wave number, so 2 pi by lambda, we'll get the expression for positions of nodes as x equal to n lambda by 2. Okay. And now we will discuss what is the expression for antinodes. Antinodes means it is their amplitude is maximum. No. So in the case of a standing wave, already we discussed expression for amplitude is given by 2a sin kx. So 2a sin kx to be maximum, what's the maximum value of sine function? It is 1, no? So sin kx should be n plus half pi by 2, no, n plus half pi by 2, or pi is equal to kx or n plus half. So we can write pi is equal to 2 pi by lambda into x, or we can write n plus half pi. N plus half pi. Is it clear? Or positions of, nodes, not positions of antinodes are represented by x equal to n plus half lambda by 2. How we can equate that to this? No, sin kx equal to n plus half pi, and k can be written as 2 pi by lambda. So we will get the positions of antinodes as n plus half lambda by 2. Okay, is it clear? So here also we can see that half will be there, but lambda by 2 is the separation between two consecutive nodes. Similarly, lambda by 2 is the separation between two consecutive antinodes. Okay, so here you have to correct in the third, from the top third line you have to correct the positions of nodes. It is not positions of antinodes. Okay. So here this is the, you can see in the case of a string the wave pattern will be like this. Next we will discuss that only. So here you can see that those nodes means where amplitude is 0. Okay, you can see that with the black that it is represented as nodes, and antinodes you can see it is shown by red and blue where amplitudes are maximum, that is antinodes. So in the case of a standing wave, that is formation of a standing wave in a stretched string, how it is formed. So here two sinusoidal waves of same amplitude travel along the string in opposite directions. Okay, and here 4 pictures are shown. The set of pictures represent the state of displacement of 4 displacement at 4 different times. Okay, it shows the displacement at different times. The displacement at positions marked as n is 0 at all times. Okay, so here you can see that n equal to 0, there all the time amplitude will be 0, so displacement will be 0. These positions are called nodes. Okay, so here you can see that how that wave, when the wave is moving at different time intervals only it is showing. First corresponds to t by 10, t stands for the time period, t by 10. Second graph corresponds to 2t by 10, third graph corresponds to 3t by 10, and fourth graph corresponds to 4t by 10. Okay. So in the case of a stretched string, that is nodes and antinodes, that is if both the ends are closed. If both the ends are closed means we can say that both are rigid boundary. So if there is rigid boundary, we know that there is no displacement at the rigid boundary. So amplitude will be 0. What it shows at the rigid boundary, nodes will be formed. No. So standing wave in the case of a string having length L, which is fixed at both ends, have restricted wavelength. Okay, any wavelength is not possible for the string. It will not vibrate with any wavelength. There is some restricted wavelength will be there if both ends of the strings are fixed. This means wave will vibrate for certain specific value of wavelength. How? In the case of both ends, we discussed nodes will be formed. Why nodes are formed? Because it is rigid boundary. At the rigid boundary, no displacement will be there. So amplitude is equal to 0. And we know the expression for node that already we discussed, x equal to n lambda by 2. This is true for x equal to 0 and x equal to L also. Okay, x equal to 0 means one end of the string, and x equal to L means other end. Both ends are fixed. So when x equal to L, we can write L is equal to n lambda by 2, or lambda is equal to 2L by n. What's the value of n? N starts from 1, 2, 3, 4, etc. Okay. So here from this expression you can see that wavelength cannot take any value, but it can take definite values which satisfies this equation, lambda is equal to 2L by n. So wavelength depends on the length of the string. Okay. That's why we can say that the standing wave on a string which is tied on both ends has the restricted wavelength. And as wavelength is restricted, we can say wave number also will be restricted, or we can say frequencies also will be restricted. No, any frequency it cannot vibrate with any frequency. So we know that frequency is equal to V by lambda. So correspondingly we can find, you can substitute for lambda. So what you will get, frequency is given by NV by 2L. V stands for the speed of the wave in the string. So these are the natural frequencies or mode of oscillation. Okay. So frequency is produced in a string which is fixed on both ends. That frequency expression for frequency is given by NV by 2L. What is V? V stands for the speed of the waves and L is the length of the string. Okay, and all integer values. Okay. So here we can find, by substituting n is equal to 1, n is equal to 2, like that we will get different modes of oscillations. So first harmonic corresponds to n is equal to 1. Okay, that is a fundamental frequency with which it can oscillate. So if you substitute n is equal to 1, what you will get? V1 can be written as n stands for 1. So 1 into V by 2L. So V by 2L, that is the least possible value of frequency for a string that can oscillate when both ends are fixed. Okay, so we can say two nodes at the ends, and in between one antinode will be there. Okay, and now stands for second harmonic. Second harmonic means if you substitute n is equal to 2. So V2 can be written as 2 into V by 2L. So you will get it as V by L. That is a second harmonic. Okay, fundamental mode is known as first harmonic, next second harmonic, and third harmonic n is equal to 3. If you substitute, you will get 3V by 2L. Okay, so here you can see that NV by 2L is the expression. If you substitute n is equal to 1, 2, 3, etc., you will get all those modes of oscillation, modes of frequency with which it can oscillate. So this is the wave pattern, standing wave pattern. So first one corresponds to fundamental or first. So both ends should be nodes, and in between one antinode will be there. And second harmonic corresponds to both ends will be node and in between two antinodes, and so on. Okay, so this is the general expression for that position x is given by n lambda by 2, that already we discussed. Okay, so the wave pattern is clear to you all of you know. I hope so. Okay, and now we will discuss about nodes and antinodes if the system one end only closed. In the previous case, in the case of a string, both ends were closed, so both will be nodes will be formed at both ends. Here only one end is closed. So if one end is closed means that only that position will be node and open end will be antinode. No. So for a system which is closed at one end, only one node is formed at the closed end. So consider there is one fixed end and one open end, and a string is attached. Not only string, anything we can consider. Okay. So at x equal to L antinodes will be formed. So this means amplitude will be maximum at this end. So what is the condition for formation of antinode? It is given by x equal to n plus half lambda by 2, that already we discussed for condition for antinode. So instead of x we can substitute it as L, because one end is open, their antinode will be formed. So L is equal to n plus half lambda by 2, or lambda is equal to 2L by n plus half. So this expression shows that again values of wavelength are fixed. Okay, restricted. Any value it cannot take. So by taking n is equal to 1, 0, 1, 2, 3, so corresponds to different wavelength, and accordingly we can find frequency also. Nu is equal to V by lambda. If you substitute lambda, you will get nu is equal to V by 2L into n plus half. Okay. Now here also we can find different modes of oscillation. How we will find different modes of oscillation? By substituting n is equal to 0, 1, 2, 3, etc. So n is equal to 0 corresponds to low fundamental frequency or first harmonic. So what you will get? V by 4L. Okay, if you substitute n is equal to 0, you will get V by 4L. N is equal to 1, if you substitute, you will get it as 3V by 4L. N is equal to 2, if you substitute, you will get as 5V by 4L, and so on. So here you can see that only odd multiple of fundamental harmonic is there. So for a system which is closed at one end and open at other end, only odd harmonics will be there. In the previous case you can see that all harmonics were present, but here only odd harmonics are present. Okay, so this is one example here. This is known as resonance column. Here top bottom it is a rigid boundary and top is open. So what happens, top we will always antinodes will be there. So this is the graph. First graph corresponds to fundamental frequency, next corresponds to second harmonic, next corresponds to third harmonic, and so on. Okay, only odd harmonics will be present. And now we will discuss about beats. So beats means it is a phenomenon caused by two sound waves of nearly same frequencies. Okay, if two sound waves are there and if they are having almost the same frequency, not same frequency, only slight variation will be there. Okay, and if they travel in the same direction, if they superimpose, that will produce beats. So here in the graph pattern you can see that there is slight variation in frequency. So you can see that one line is drawn. Okay, so there what happens, the first wave's crest and the second wave's trough is meeting. So at that point minimum intensity will be there. So minimum amplitude will be there. So like that pattern you can see. Okay, is it clear? So because of which beats will be produced due to slight variation in frequencies, and if they travel in the same direction, that will produce beat. And example for beats, so many examples are there, practical applications of beats are there. It is used in tuning of musical instruments. For tuning musical instruments, we are using the phenomenon of beats. Okay, so tuning of musical instruments like piano, harmonium, etc. So before we start playing on the musical instruments, they are set against the standard frequency. If it is not set, a striking noise will keep on coming till it is set. Okay, so beat, by using the phenomenon of beat, they will tune the musical instruments. And another use is that to determine unknown frequency. If we don't know the frequency of some tuning fork or some instrument, we can find its frequency by using different methods are there that we will discuss later. Okay, and next one is for producing colorful effects in music. Okay, with the help of beats we can have colorful effect in music. And next it is used for detection of marsh gas in mines. Okay, by using beats we can detect marsh gas in mines. Similarly, it is used in electronics to get low frequency oscillation. To get low frequency it is very difficult. So two waves will be slightly varying waves will be used. With the help of those we will get low frequency. Okay, that can be produced by using beats. Okay, so these are the different applications or different uses of beats. So now we will discuss the mathematical expression for beats. So we are considering two time dependent and not position dependent part of the wave. Okay, we are considering only the time dependent and we are not bothered about the position dependent part of the wave. Okay, so one is considered as, first wave we are taking it as a cos omega 1t, and second wave we are considering it as a cos omega 2t. Both are having same amplitude a and difference frequencies omega 1 and omega 2, and we are assuming that omega 1 is greater than omega 2. Vice versa also you can consider. Accordingly you will get the expression. Okay, so here when I am considering, when I am discussing this derivation, I am assuming that omega 1 is greater than omega 2. So if they superimpose, what happens, what will be the resultant displacement, that is given by y1 plus y2. Here is we are representing it as s1 and s2. So resultant displacement we can write it as s1 plus s2, that is equal to a cos omega 1t plus a cos omega 2t. A can be taken common, so cos omega 1t plus cos omega 2t into a. So if you simplify, what you will get, cos a plus cos b can be written as cos a minus b by 2 cos a plus b by 2. That already you might have studied in trigonometry, no? So if you simplify, what you will get, 2a cos omega 1 minus omega 2 by 2 into t, and cos omega 1 plus omega 2 by 2 into t. And omega 1 minus omega 2 is very small because both are having almost same frequency. and it is already given omega 1 is greater than omega 2. So we are taking it as omega 1 minus omega 2 by 2 can be written as omega b, and omega 1 plus omega 2 is very large, and omega 1 plus omega 2 by 2 we are writing it as omega a. So what we got the net displacement, that we got it as 2a cos omega bt cos omega at. So cos omega at will vary rapidly with time, and 2a cos omega bt will change slowly with time. Why? Because cos omega b value is very small in comparison with omega. So we can say 2a cos omega bt can be considered as the amplitude of the wave, and cos omega t, that is the variation of time dependent variation of that resultant displacement. Okay. So here beat frequency, we are defining beat frequency as the difference in frequencies of the two waves. Okay. So the difference in frequency of the two waves are known as beat frequency. So if one is having frequency omega 1, another is having frequency, means here angular frequency. Okay. When we are writing omega 1 and omega 2, even though we are writing it is frequency, you should know that it is angular frequency or angular velocity. Okay. So omega 1 and omega 2 are the different two frequencies. So beat frequency we can write it as omega 1 and omega 1 minus omega 2, or if nu, that frequency we can write it as nu 1 minus nu 2, where nu 1 and nu 2 are their frequencies. Okay, is it clear? So today we discussed about the expression for nodes and antinodes, and in the case of what's the expression for fundamental frequency and first harmonics in the case of a stretch, in the case of a string which is fixed at both ends, and if one part is rigid and another part is fixed, one end is fixed and another end is free, in that case also we discussed. Then we discussed about beats and its practical applications and mathematical formula. I hope all of you understood. If you are having any doubt, communicate that to me. Thank you.